Okay, welcome to the second video on SQL querying. In the first video, which I'm going to assume you watched, we considered a bunch of queries on single tables. Now, some of the queries are reasonably complex, but querying individual tables isn't something you tend to do so often in practice. The real power of databases comes from being able to combine the information combined in multiple tables. And that's what we're going to focus on in this video. Now, of course, the way that you combine information from tables in relational databases is using the join operation. Okay, so we're going to use the same database as we used last time, the football database, but we're going to consider queries that require us to put together information from several tables. So if you remember, at the start of the last video, I said that typically queries arise in relation to an information request. And the first thing to do is identify where does the data come from. In all of these queries, the next thing to do is going to be to identify how do we put the various tables containing the various data items together. And then finally, how do we render them? Okay, so looking at the first query, list each player and their team. There's the database, and we know that the relationship between players and teams is actually encapsulated in an attribute in the player table. So we've got this member of attribute, and we can see that member of is a foreign key that refers to the team ID. So that's the link between the player table and the team table. So what we want to do is do a join operation that puts together the player and the particular team that that player is a member of. So I'll jump into the editor to do all of these. So let's just get started looking at the join operation. So we're interested in the player, and actually I'll save that for later, and the team. And the condition that we're joining on is that the member of attribute in the player table corresponds to the ID attribute in the team table. And the way that you say that in Postgres is something like this. So the team that the player is a member of is equal to a particular tuple in the team table that has the same ID. So that would put the two tables, information about the two tables together. If I ran that query and just looked at all of the attributes of each tuple, what we'd see is that it contained all of the attributes in the player table and all of the attributes from the team table. So let's just see. It might help if I put a semicolon. Let's just see what results from this. Okay, so you can see we've got an ID, which is the player ID, the player's name, the player's birthday, the team that they're a member of, the position that they play, then the team ID, and the country corresponding to that team. Now, for every tuple in this table, we should have the member of is equal to ID. I guess the other thing to notice here is that we've got two ID attributes. That can be a little bit confusing. And so you may have noticed that in the query, we qualified each attribute by mentioning the name of the table. So that's how we can disambiguate ID. If we're talking about the team ID, we write team.id. If we're talking about the player's ID, then we write player.id. Now, actually writing the full table name each time is slightly tedious, and you can actually abbreviate by defining an alias for each of the tables and then using that alias. So that would do the trick. Now, the actual query is to list each player and their team. Generally, when you say each player, you mean the name of the player. So the player's name, and the team country, but let's say that we would rather have the column heading as team. So that would probably be a suitable way to answer this query, and it would give a result that looks something like that. Okay, so Diego Maradona plays for Argentina, all of the other Argentinian players, then Bruce Smith plays for Australia, all of the other Australian players, the Brazilian players, the Chinese players, English players, and so on. Okay, so that join puts together information from player and team, and then we extract out just the particular attribute values that we actually want from each of those tuples. Alright, so that's that for that query. Let's take a look at the next information request. What is the average age of each team? Okay, well, if we look here, we're actually part way to solving that problem. Joining the player age information is in the player table, obviously, and the team name, which is one of the things that we want here, is in the team table. So we still need to do this join, but this time maybe we're not interested in the player names. We're really only interested in the age, because we're trying to find the average age of each team. Okay, so what we could do is do the age of the player by using their birthday and the age function to compute that. And that would give us a list of countries and the name of each player for each country. So let's have a quick look at that. The result of that query. So this is going to give us all the Argentinian players and the age for each player. So what we're interested in doing is working out an average of the set of ages in that highlighted region of the result. And if you remember from the previous video, we can do that by doing group by, grouping by the team, and then selecting a property of the group, in this case we're going to select the average age. So getting the group, and PostgreSQL has a built-in function average, AVG, and what we want to do is we want to group by team. So something like that. So we group by the country, and then within each group we compute the average age. So that should give us a result something like that. And if we really wanted to, we could use that to work out which is the youngest or the oldest team. And of course, as I mentioned in the previous video, I made this database a long time ago, and so the players have apparently aged 10 years in the meantime, which would be true if it was the same players still playing. Okay, so that'll give me the average age of each team, and if I wanted to answer the query, say, what's the youngest team, then I could use that query to pull out the minimum average age, and then feed that minimum value into a query to get the name of the actual team. And we saw an example of doing that kind of thing in the previous video. Alright, let's look at the next query. How many matches did Diego Maradona play in? Okay, so what tables are relevant here? So I think we can dispose of that. So definitely we're interested in player, because we need to know the name Diego Maradona. Now, how do we know what matches they were involved in? Well, a player is a member of a team, and a team is involved in matches. Now, it's interesting in this database that there's no direct link between a player and the games that they might have played in. So we're going to make the perhaps unrealistic assumption that if a player is a member of a team, he plays in every match that that team is involved in. So to solve this problem, we need to join three tables together. So we certainly need to link the player and the team, but we also need to link the team to the matches that that team was involved in. And the table for doing that is the involves table. And I'll do the same thing, define an alias. And this time the join is going to be between the team table and the involves table. And so we will have the team that's involved in the match is this particular team, and that particular team will contain a player who's a member of that team. Now, remember that the whole point was to find how many matches Diego Maradona played in, so we really need to restrict our attention to the player whose name is Diego Maradona. Okay, so we need a where clause here. So that would give us a list of all of the matches. It would give us player information, team information, and involves information. Now we don't need to see all of that information, and we certainly don't need to see the player's name, because we know that every tuple will have Diego Maradona for the name. The question was, how many matches did Diego Maradona play in? And so really all that's involved is counting the number of tuples in this result. And we don't need to group by country, so that's it. So join Diego Maradona with the team that he plays for, which is Argentina, and then find all of the matches that Argentina is involved in. That'll give us a bunch of tuples saying Diego Maradona playing for Argentina was involved in this match, and then we just count the number of tuples in that result. And that tells us that Diego played in 20 matches. Right, next question. How many goals did each player score? Okay, well, we're going to have to consider different tables this time. Well, the player table is still relevant, and even account is potentially going to be relevant, but we'll worry about that later. So what's the link between players and goals? Well, if you remember, the goal table contains a field that tells us who the goal was scored by. So that's our link between player and goal. So the join that we're going to do is who scored the goal, who was the goal scored by, and the player who scored it. And of course we don't need where the name is Maradona. So that's the essential join here. That's going to give us a bunch of tuples that have a player and a goal that that player scored. And if a player scored multiple goals, there'll be multiple tuples in that result. So let's quickly take a look at the result of that. Simply that join is going to give us a table with lots of values for each tuple. It looks messy here because there are so many attributes that the tuples are wrapping around on the output lines. But in any case, we can see here's a player and here's a goal that he scored, and this ID field is referring to the goal ID. And if we look down this column, we should find that every goal appears exactly once. Not necessarily in order, but every goal is going to appear once associated with the player who scored that goal. Okay, so the question was, how many goals did each player score? All right, well, if we took that query and we added order by, and we ordered by the player, and let's start trimming back some of the output of that. And let's just take the player name and the goal ID. So here we've captured the essential association between a player and the goals that they scored. So now we can see we've got all of the goals that this player scored, all of the goals that this player scored, and so on. So since we've got these groups, we can once again employ the group by function and simply count how many entries are in each group. So for this player, Bruce White, we can see that there are around about six goals that Bruce White scored. So the size of that group is 6. Now, a convenient way to count it would simply be to count the number of goal IDs in the group. So let's go back and modify the query to do that. So rather than order by, we now do a group by, and we count the number of goals. And so that will give us our result. How many goals did each player score? So the first player scored 1 goal, 1 goal, 1 goal. We've got a player down here who happens to have scored 13 goals. Pretty impressive. Another player here who scored 4 goals, which isn't bad. If we wanted to find out who are the top goal scorers, then it would be reasonably straightforward. We can simply add an order by and order by the count and order descending, so that the maximum number of goals scored by any one player will be first, and so on and so on. So we see that David Ponsford actually scored the most goals, way ahead of Bruce White, and so on and so on. Other names that I wouldn't dare to pronounce for fear of getting them totally wrong. Okay, so how many goals did each player score? We've dealt with that. Next question. Include players who scored no goals. One thing that should have been clear from this join is that a player is only going to appear in the result table if he actually scored a goal. Otherwise, if a player never scored a goal, there won't be any goal to be joined with, and so the player's name just won't appear in the result. So what if we want to include players who are players but have never scored a goal? Well, the way to do that is to use the outer join style of join, and in particular what we want here is we want a left outer join. Now I'll go back to this type of output and let's order by the player name again. Okay, so with a left outer join, the left means that for the table on the left, every tuple in that table is going to have an entry in the result of the outer join. So every player is going to appear if the player has scored a goal. In fact, there may be multiple tuples for a particular player for all of the goals that they scored. What happens if a player has never scored a goal? Well, rather than having a goal ID here, we're going to have a value null. So we can look at the output of that and we can see a couple of players who didn't score anything, so they end up with a null value there. And since I've ordered by players, you can see that once again we've got the groups. So what we're interested in, for the players who have scored goals, we do a group by and we simply count the number of goals. For players who haven't scored any goals, we've got a group which has a single tuple in it with a null value for the ID. Now it turns out that in Postgres, if you count null values, you get the result 0. So what we can do here is count the goal IDs. So we go back to our group by and let's order by the count with, in this case, ascending. So all the people who scored 0 goals should come first in the output. So let's take a look at the result there. So all of these players scored no goals. They would have appeared in the the result of the query that we just looked at, a single entry with a null. Let's keep scrolling. Now we've found the people who scored 1 goal, and if we keep going, we get down to the high goal scorers down the end. So every player appears in that output, whether they scored goals or not. Okay, so that's that question answered. Next question. Who has scored more than 1 amazing goal? All right, so we're still back dealing with players and the goals they've scored. So in this case, we're not going to do an outer join. You don't score an amazing goal if you don't score a goal. So we can go back to a regular join. But this time what we want to do is we want to restrict ourselves just to goals where the rating is amazing. And we can still group by the player, that makes sense. But let's take a look at, still wanted to order by the player's name. So let's take a look at the output of this. And once again, we'll see those groups that form. Ooh. Oops. Okay. I think I mentioned in the previous video that if you're using group by, then you need to make sure that all of the attributes mentioned in the group by appear in the select clause and no other attributes appear, and the only other things that appear in the select clause are aggregates, because the sequence of attributes identifies, if you like, the signature of the group, and then the rest of the attributes on the select line are basically single values that characterize or summarize some aspect of that group. I must have put what? So in fact, the problem was that I'd put an aggregate rather than a straight attribute. Okay, so now we can see, so all of these goals will be amazing because that was what the where clause asked for. And what we want to do, once again, we've got groups, so we want to count the size of each group. But the query actually says more than 1 amazing goal. So if you remember from the previous example, there was a way of filtering based on a property of the group, and that is using having. So having the count of the number of goals in the group being greater than 1. And since we're doing a group by, we now have to return to having a single value associated with the group, so we could count the number of goals. Or we could even omit the count altogether and just print the player's name, which, if you like, is an answer to that query. But anyway, we'll leave the count in. So join player and goal, select it, filter out only the goals that are amazing, then group by the player's name, so a set of amazing goals by each particular player. Make sure that the group of goals is larger than size 1, and then for each such group we print the player name and the count. So let's take a look at that. So that summarizes what we're after with that particular query. Okay, so that question dealt with. Next question. Get a list of matches that includes the teams, the place, and the date. So where did the match occur, what date was it played, and who are the teams that are involved in it? Alright, so let's go back here. So we've got the involves table, we've got the teams which contain the team names, we've got the matches table, or the match table, which contains information about the match, like the place and the date. This query is slightly interesting. well, they're all interesting, but this one is a little bit more interesting because we've got to join two separate tuples in the teams table against the matches table because we know that two teams are involved in each match. So let's go back to our editor. Start from nothing. So we got not interested in players anymore. Neither are we interested in goals. In fact, we can delete all of that. Okay. So what we are interested in is the matches, and we want to join the matches with involves, and then we want to join with team. Now that's, if we simply had that, that would give us a match and it would join with both of the teams that were involved, but the result of that join would be in separate tuples. We want to get everything into a single tuple, and that requires us to actually have, if you like, a five-way join, where we join the match. We've got a single match. We want to join against two separate teams as part of the same large join. So we're going to have to have one team, and we're going to have another team, and these teams are going to be linked to the match by separate entries in the involves table. So the thing that's linking all of this together is the fact that they're all part of the same match. Okay, so what are the join conditions that we're interested in here? All right, so team 1 has to be joined with involves 1, or that's the way we're going to express it. So team1.id is the team that comes from the I1 tuple of the involves table. Team 2 is going to be the team that comes from the I2 tuple in the involves table. Now, the thing that links the two teams to a single match is the fact that we want both of the involves tuples to involve the same, to be involved in the same match. So I1, the match for the I1 tuple is equal to m.id, and the match for the I2 tuple is the same match. Okay, so that's a little bit weird. So let's take a look. If we displayed a tuple like that, it would be very large because it involves attributes from 5 different tables. So let's try and extract the ones that we actually want. Let's grab the match ID and maybe the 2 team names, just for the time being. Okay, and let's, for the sake of argument, order by the match. So we'll get all the tuples associated with a given match appearing in order. Oh, what did I do wrong? Oh, okay. So you'll get this if you don't associate an alias with a table. And I presume what I forgot to do. Nope. Interesting. Let's try a little bit of debugging on the fly. Oh yes, that's true. So the team name isn't called name, it's called country. And okay, it looks like Postgres isn't happy if this appears in a join before it's actually defined as an alias. So that was the reason for that first error. Alright, so good. Okay, so what we've got here are the tuples that result from that five-way join. Now you can see one thing that's a little bit interesting and somewhat annoying is that we've got for a particular match, match 1 between China and Brazil, we've got sort of every combination of the two teams being mentioned here. Now we really only want one. We want to know that it's a match between Brazil and China, or between China and Brazil. So we really need to filter out the tuples, and the trick here is to simply put in a where clause that says we only want the pair where, say, the first country happens to have a name that's less than the second country, and that will eliminate all the other tuples. So you won't get Brazil, Brazil, you won't get China, China, and you won't get China and Brazil. The only one you'll get is Brazil because it's less than China, or this tuple here. So let's add the trick. And we'll get something that's a little bit more sensible. Okay, so each match now has only one tuple. And if we were to scroll down, we'd see that. Okay, every match appears once. All right, so we're getting pretty close to the result that we want, but what we're actually after was the teams, the place, and the date. We're not interested in the match ID, except to make the join work. So we're using it here, but we're certainly not interested in displaying it. But what we are interested in displaying is the place that the match was played and when it was played. And I'm guessing the name of the fields right here. I should have checked the database first, but let's see if that worked. No. So what's the field called in the match table? It's called city. Okay. Okay, so now we've got something that approximates what was asked for. We want the teams, the place where the match was played, and the date that it was played. And if we want, we can scroll through all of the solutions there. There's 100 matches in our database. Okay, I guess the one thing you could argue against the result of this tuple is that putting that the Iran-Korea match was played in Busan, if you wanted to always put the home team first, you've got a problem because there's no link between the place where it was played and the country where that place is located. So it simply wouldn't be possible to put the home team first given this. So we always write the teams in alphabetical order, but that will do for that query. It contains the essential information anyway. Okay, one more, and this is really just going to be a tease. I want tuples like this, but I want also to have the goal. So if the result of the Brazil-England match was Brazil 5, England 1, played in Manchester on that date, that's what I want to see on the output line. Brazil 1, Brazil 5, England 1, played in Manchester. So answering that query requires a lot of messing around, and it requires us or it can be most easily solved if we make use of the SQL view idea. So we'll talk about that in the next video. So that's it for this video about SQL queries involving multiple tables.